A lot of people get excited about electric propulsion in aviation. Electric motors offer high torque, impressive efficiency, and zero direct emissions, which sounds perfect for aircraft. But there's a big obstacle that has kept fully electric planes from becoming mainstream: batteries. Compared to aviation fuel, batteries store far less energy for the same weight. In fact, jet fuel can hold more than 20 times the energy per kilogram. Because of that, if you tried to power a typical regional aircraft entirely with batteries, a huge portion of the aircraft's weight would be taken up by the battery pack. That leaves less room for passengers or cargo, and limits range, which is why most all-electric aircraft concepts today can only fly about 150 nautical miles or so. There's another problem too. In a traditional aircraft, the plane gets lighter as it burns fuel during the flight. That makes it more efficient over time. Electric aircraft don't have that advantage because the batteries weigh the same at takeoff and landing. Even when the charge is nearly gone, the plane is still carrying the full battery weight. Add in challenges like battery cooling and the need for powerful charging infrastructure at airports, and it's clear why fully electric regional aircraft are still a tough challenge. That said, electric propulsion does bring real advantages. Engineers just need a smarter way to use it without sacrificing the performance airlines need. This is where hybrid systems come in, and that's exactly what RTX is working on. RTX, through its subsidiary Pratt & Whitney Canada, has teamed up with Collins Aerospace and the Canadian government to develop a hybrid electric turboprop system designed for regional aircraft. Recently, the project hit a major milestone. On March 3, 2026, the system successfully ran at full power during a ground test in Longueuil, Quebec, where engineers tested the integrated propulsion system and battery setup together in a controlled test cell. Now, if you're thinking about hybrid cars, this aircraft system works a little differently from something like a typical hybrid vehicle. In many cars, the gasoline engine charges the batteries, which then power the electric motor. In this new aviation system, both power sources actually work together. The setup combines a modified version of Pratt & Whitney's PW127XT turboprop engine with a 1 megawatt electric motor developed by Collins Aerospace. Both are connected through a specialized gearbox, so they can drive the propeller shaft at the same time. Instead of taking turns, the thermal engine and the electric motor share the workload. This approach helps smooth out how the engine operates. Normally, turboprop engines have to ramp up dramatically during takeoff and climb. With the hybrid system, the electric motor can provide an extra boost during those high-power moments, allowing the main engine to run closer to a steady throttle setting. At full output, the system can deliver up to 2 megawatts of combined power. There's another clever feature too. During descent, the electric motor can act as a generator, recovering some energy and sending it back into the aircraft's 200 kilowatt-hour battery pack. That helps recharge the system and improves overall efficiency. The goal of the project is ambitious. Engineers are aiming for around a 30% reduction in fuel consumption and about 20% lower maintenance costs compared with traditional systems. The engine is also designed to run on 100% sustainable aviation fuel, which could further reduce its environmental impact. One of the most interesting aspects of this project is that it isn't designed only for brand new aircraft. The companies involved say the hybrid system could potentially be retrofitted into existing regional turboprops. For airlines, that could be a big deal because it means they might be able to upgrade their fleets to a more efficient and greener system without buying entirely new aircraft. Testing is far from over. Ground testing is expected to continue throughout 2026. After that, the team plans to move into flight testing at Moses Lake in Washington, using a modified Dash 8-100 aircraft as the flying test platform. If everything goes as planned, this hybrid approach could become an important stepping stone for the aviation industry, offering better efficiency and lower emissions while still keeping the range and performance airlines rely on.